We're going to conclude today our Rust machine learning framework. We're going to walk through it. We're going to see all the details, understand kind of how it works, and then we're going to mess with it. We're going to start cooking with some Threven and Throd demonstrations. I haven't ever done this before, but I think it will be kind of neat. What we can do is we can use this AI model to learn how to detect like odd and even numbers, but we can also have it detect Threven and Throd numbers. If you didn't know, yes, you can. This is a thing. It sounds like it's fake, doesn't it? Threven and Throd. It sounds fake, but it's real. It's a real thing. Basically, you can find numbers divisible by 3. And we can train an AI model, especially a deep learning model. And I believe it doesn't even need to be a deep learning model because that is it can be a linear model for sure. So, but we're going to do it with a deep learning model anyway. It's overkill. We're going to overcook the Threven and Throds. I'm really excited about that. That's going to be the plan today. I know we can get to it. Often we get, distracted and we, move off onto, tangents, but today we will get through Threven and Throd, and that will be the goal. We'll also walk through the XOR nonlinear example that was demonstrated. So that's the plan for today. This is all our Rust code, and it's all compiled, and it runs. I believe it's only for. Hey, Ashford, good to see you. Welcome in. We're going to conclude today our Rust machine learning framework. We're going to see how it works. And then we're going to make maybe some modifications to it if there's time. But we want to play with it. We want to cook. We want to say, let's get it working with. Let's train it on Threven and Throd numbers. Train it on Threven and Throd. I think we can do it. I've never done it before. I'm pretty sure it's possible, and we'll find out. It might not work. I'm pretty sure. I'm pretty sure it'll work. So let's jump in. So we've got some files here. Just to know, I believe the main RS is pretty small. It's just a run. It's like a throwaway file for the most part. So we don't really need to do much with that. But check this out. I do believe we were walking through the layers file in our previous stream, so we can kind of continue onward with that. Check this out. Okay, so this is the only layer that we have in all of our framework here. It's just the dense layer, which just means two-dimensional array, basically. Multi-dimensional array, and with a bias. And so basically this is it. We're looking at it right here. These two lines is what it is. There are inputs and output. Concluding today the Rust machine learning framework that we had, and we're going to walk through it really quick. We have time today to do that. We have time to walk through it. We're going to learn the details about it, and then we're going to use it. Then we're going to use it to build some toy models, and something I've never done before, but I'm pretty sure is possible: a Threven and Throd detector. We're going to write a Threven and Throd detector with the AI model. I'm pretty sure it's possible. We're going to find out. We'll try, and we'll see if it works. So. But we're looking right now at the dense layer, which is just a simple 2D matrix with a bias, which is a one-dimensional matrix. Yep. So you can see here how it works. So array with zeros, and then n number neurons. That's just like how dense is going to be this array. How many elements in the array is there going to be? But we call it neurons. I don't know why we call it neurons, or number of parameters or weights in it. Shrujan, hey sir, can you send the GitHub link? Sure, absolutely. I know we have it. We definitely have it. So it will be, let's do this. Let's go to github.com, Stephen Blum. Here we go, Stephen LB. And then it should be around here somewhere. Repositories. All right, here we go. It should be at the very top. There we go. Rust machine learning. Here we go. This is it right here. We are doing some Rust today. We're walking through some Rust machine learning. It's all CPU based. So this is like minimal like machine learning. We're not going to use any GPU acceleration today. 10 meg, great, going great. Excellent. That's good to hear. We're going to walk through this code base, and then we're going to play with it. We're going to cook. We're going to create a Threven and Throd detector. I know it's possible. I'm pretty sure. Vivek, hey, how's it going? Good to have you here. We are going to jump into the code. So walking through it, this is the most important. If you're talking about where does the knowledge sit in the AI. Where's the brain? Where's the brain? Right there, here on these 2 lines. On these 2 lines right here, we're looking at right here. The weights and the biases. The two-dimensional array here, and then a one-dimensional array with the neurons, which just basically means the number of elements or the number of parameters, Here we go. And then there's some nice things to have when you're doing training. You don't need most of this. It is a CPU base and a minimum use of GPU. Then I can use my project. Oh, you can? Yeah. Okay, perfect. Yeah, it's good to go. It is actually completely usable as is, and you can build the majority of all AI projects that you need with it. And so it is single CPU right now. I don't think there's any concurrency baked in because I haven't run into it, but you could easily bake in some concurrency, especially that you'd want like during training. During inferencing time, you don't necessarily need any concurrency. You probably could have, you just launch multiple instances. You could do forks. you can fork it. You do multiple instances. So there's no need. You just one process per container, and then you can get concurrency that way. But for training, we could make this multi-processed. Like we could submit the workload to train and then capture gradients from different threads, for example. We could do something like that to accelerate the training on a CPU style model. But you know what? If you got a GPU, we could probably just use GPU compute acceleration with matrix multiplications. We don't want to do that today because we're just gonna mess around. We're just gonna have fun. So the brain is here, weights and biases, the inputs and outputs, THT. This is Rust Deep Learning using the Rust programming language. We have a minimal machine deep learning framework, basically a minimal deep learning framework. Pretty small. It's concise, and it has a few like extras for the training phase, things that aren't always necessary but help accelerate it on CPU. So we're only using CPU today. We're not going to use GPU. And then once we walk through the framework that we have here, we're going to use it. We're going to cook with it. We're going to build a Threven and Throd detector. Check this out. Threven and Throd. These are real words. It's Threven and Throd are a pair of informal, recently proposed neologisms of a mathematical community that extend the concept of even and odd numbers. Yeah. All right. So it's new, right? It's a new kind of thing. So we're gonna build an AI to detect those numbers. Isn't that cool? So we're gonna build an AI to detect that today. That's what we're gonna do. Tanmay, are we making a deep learning model using Rust can deploy that blockchains? Yes, you could actually. You totally could. So what is it? Solana and any blockchain that supports Rust or a WASM container. Of course, Rust can be compiled to most target binaries for any of the operating systems and platforms or like different processor types. WASM is a nice sort of like universal container that can run on most CPUs. So yeah, I think WASM will work. So you just target your Rust to compile the WASM, and you can do it. And so you can build an AI system that runs in WASM on the blockchain. Now, guess what you've just done? You know what you've just done, Tanmay? You've created an AI inside of the blockchain. That's what you just did. And you can totally do that. And you can do it with this repository as well. All you have to do is target WASM, and then you can deploy it onto like this. This just lets you predefine your own weights and biases. And you might want to do that if you want a different kind of distribution. For example, a random uniform of numbers in your matrix between -1 and +1. This is kind of interesting. So what I found is when you are creating AI models, you want to have a uniform random initial weight activation and biases too, really. Although in this case, it's not happening here, but it's got to be between -1 and +1. We're gonna have a little bit of extra time today. We are gonna get to go through, and we're gonna have the capability to build cook with. We're gonna cook with this model. We're gonna build our own Threven and Throd model. Basically, like it's detecting even and odd numbers. Nazar, hey Nazar, how's it going? Happy to have you here. We're working with Rust today with a machine learning framework. It'll be deep learning. And we're gonna walk through it really quick. So that's what we're doing right now. We're walking through the Rust deep learning framework. And we will be, so what are we doing today? Yep, Milan John. That's the plan. We're going to be walking through the Rust deep learning. Hey, thank you for the likes. Appreciate it. Woo, love it. So good. What programming language are you using? This is Rust. This is the Rust programming language. Rust has the performance of C, but it's got extra benefits that most languages don't have, including concurrency safety and memory safety. Now, you might say, hey, Stephen, hold on a second. I heard that Java and some other languages have these safeties built in, but they only have them built in at runtime, and they don't have it built in at compile time. That's where Rust is special. Hey, thank you for the likes. This is why Rust is amazing. It builds it at compile time. It checks all of the concurrency problems that you'd run into and any of the memory challenges. But it's hard to work with. So it's really strict. What type of LLM are you about to build? We are building a basic machine learning. We're not going to be building generative AI, but we can add a self-attention on top of this, and then we can also have the outputs be a softmax across a bunch of different token outputs. And we could build an LLM if we wanted to using this very framework. It's not that far off. All you have to do is we probably do like a letter-based, so an alphabet. So just like what A to Z. We use a 10H activation function, but is there a predefined module in Rust? So yeah, you can use 10H, and we have an activation here. Check this out, activations. We have a 10H here. There you go. And it's using, I do believe it's called, it's a built-in 10H, which is coming from ND Array. It's called ND Array. So you can use ND Array, and it's got built-in math for that. It's kind of like NumPy in Python, but it's for Rust. Yeah. The framework here. We want to get back to our framework. Neat. Nasser, thank you for the explanation, sir. So what kind of model are you going to build with it? CNN, RNN, or LM? This is none of those. It's none of them. It will be just a standard sort of multi-dimensional regressive model, or sort of like a support vector machine. I think it's more along SVM is what we're doing, but with a dense SVM. That's what we're building. Dense. Here we go. Dense SVM, support vector machine. That's more along the lines of what we're building. And it's just a simple version where it's just the weights, it's just the biases, it has the activations, and then it does a forward pass, and then we can do back pass in gradient, using gradients to train the model. That's what we're going to do. That's what we're planning to do. To ask whether you have experience with autodiff. So if you don't have to write backwards past yourself, that's interesting. I don't have experience with autodiff. Let's see here. Let's get back to the programming language here. But AutoML, yeah, that makes, I played with AutoML, but autodiff might be the same thing, right? It might be similar. We'll have to look it up later. It's probably a really good. And C, you could use C as well and target WASM, I believe. Mohammed, hey, how does Rust connect to deep learning? So deep learning is just, essentially a set of algorithms, and all languages, including JavaScript or TypeScript or Python, or no matter what, C, C++, Kotlin, Java, you name it, Elixir, all of them, they can all do deep learning because it's just a simple algorithm. It's not too complex. It's the best programming language in the whole history of the universe and multiverse. It is, because I think so. Here's why. Because we've got a business, PubNub, and we use it to connect over 1 billion devices, and we use Rust, and Rust has saved us so much performance. It has netted us a huge amount of win on latency. It's like a 10x. I wrote an OS macro kernel or microkernel in Rust. Did you an OS microkernel? So something that can handle sort of distributing work between processes or threads on a machine that's probably like an RTOS of some sort. With Rust, AI agent microservices with dedicated runtime in each could literally automate my whole computation workflow. So that's really cool. Okay, so you've kind of written your own orchestration, essentially is what you're telling me, Alfie. That's actually really powerful. Jambuster, you believe in Rust and C and its compute super fast capabilities. Yeah, it is. And storage to create AI models from scratch. Yeah, but it's not a beginner friendly. It's not. It's not. It's one of the hardest languages to learn, in my opinion, other than like say maybe Haskell or Lisp. Those languages are challenging. Haskell and Lisp are challenging languages, but yeah, Rust is probably the most beneficial to learn by far. But you're right, Jambuster. It's not a beginner-friendly language. Hey, Shyam. Hey, Steven, how are you? Doing good. We're walking through our Rust deep learning machine learning framework here, and we're gonna cook with it. We're gonna use it, and we're gonna build some toy models, and we'll show you how it works. We're going to walk through it. So we mostly got through it here. That was one of the most incredible things I did with Rust and made me extremely in love with Rust because you can literally build anything. You can totally build anything and it will be fast and from your brain and a neural network to a microkernel and it all. Yes, and you can build and you can deploy to IoT devices because of the low footprint. I love speaking neural network more than ANN. Yes, this is kind of like an ANN, to be honest. A neuromorphic AI. That sounds interesting. Rust is a language that makes me believe I can build anything. Yeah, it really is. It's just so good. I love it. And it was one of the most difficult things to learn, but it's absolutely worth it. All right, so let's jump back into the code here. So we have our activations here at the top we saw. We've got tanh, sigmoid, and ReLU. That's all we need. We don't need any others. Okay. And we've got our dense layer, and we've implemented the dense layer with a forward pass and a back pass. Forward pass is to get our inference so we can detect what the outcome is, and then the backward pass is for training. And these are all helper functions here, and that's it for there. All right, we're getting through it, you guys. All right, let's open up losses. This is how we detect how wrong the model is. When a model makes a prediction and we know what the answer is already, we can calculate how wrong it was. It's like, hey, model, you predicted this answer, but you were wrong, and you were off by 10, for example, by a quantity. Then we can take that loss and apply it in back propagation to the model's weights and apply it based with a learning rate to slowly adjust the weights to make it learn. That's how the model learns. It's really cool. Here we go. Mean squared error. Okay. Interesting. Oh, neat. Okay. I see kind of how. So it's you can. I wasn't aware that you needed to have loss for back. I suppose to calculate the gradients. So you've got a forward to calculate loss, but then the gradients back. Bro, to build. Oh wait, what's array 2? Oh right. Nirjar. Array 2 is a two-dimensional array. If that answer is, it's two-dimensional array, basically. An ND array is kind of sort of like NumPy, but for Rust. ND array is like NumPy, but for Rust, because it's got built-ins that make it a little bit easy. But NumPy is better because I like it a little bit better because it has some nicer syntactic sugar. But Rust can't get to all of it. It can only do a little bit. It can do just a little bit, but not as much as Python. Let's see here. Bro, you built your personal assistant with Python, which is another combo will be better, bro. Oh, really? To build your personal assistant? Yes, Python. Definitely use Python for those kinds of projects because it's easier to maintain and build and read. This code you're seeing on the screen, there's a lot of symbols everywhere. There's a lot of ampersands. There's like angle brackets. There's semicolons. There's arrows. It's just a lot going on here. But it's necessary for the compiler. But you don't need that if you're using Python, which is really cool, right? We could have used PyTorch for Rust. There is a PyTorch-like. You can use libtorch. So Alfie, libtorch is the C++ library that PyTorch uses. You can also use that in any other language. You can use essentially PyTorch or libtorch in Rust. You can do that as well. And we might even do that because it gives you the ability to access the GPU to accelerate the compute of your AI. So that's open source. I'll paste in the window here your link to the open source project. All right, here we go. Let's paste that in. Here's the open source code for you guys. You can have it, and guess what? This will work in any environment. It'll work in WASM. It'll work in smart contracts. It'll work for wherever you want to deploy it. It works everywhere. It's universally supported, and it has almost no dependencies. So it's really efficient, it's lean, and it's powerful, and you can cook anything you want with it. It's really cool. Deep learning with Rust. Yeah, quantified quantum. You can totally do deep learning with Rust. You can absolutely do it. And we did it. We actually did it. And you want to do that for things that are like non-linear things to learn. For like example, the operator, the XOR operator. which is a nonlinear operator, you can do that. And that's what we did. That's what we did here. But here, close that. We don't need that anymore. All right. So we just looked through our losses, which is mean squared error. Yeah, libtorch is amazing. It is. Alpha, you're totally right. Libtorch. Open source. Oh, I pasted the link. Okay, collector. And it has pauses. At PubNub, we could not use Go because it is not fast enough for us. It is not a fast enough language. We have to use C or Rust because we have 1 billion connected devices. So Rust or C are the only options for us. At our scale, Go is just not quite fast enough. But it will work and it'll do the job and it gets things going quicker. So choose Rust or C is my recommendation. This a PyTorch transformers is what you want to do. This is Meta or Facebook's technology, and I believe OpenAI and Anthropic use it as well. Yeah. So see here, Alfie, let's build an SNN in Rust, a brain-inspired neuromorphic neural network named Spiking Neural Network. Oh, Spiking, I remember Spiking Neural Network, which it can train and works on a single battery instead of millions of GPU clusters. That sounds cool. Also apply for C jobs or Python jobs as well, or any job, because you can use Rust. We did another stream recently where we showed how you could use Rust in any other language. Basically, we showed how to use it in Python. So you can write your code in Rust and then call your Rust code from Python, for example, by compiling a Rust library and then importing it into Python. So you can do that as well. So basically, if you want to use Rust, you can do that with any language for the most part. LLM Python is okay, but other languages, which makes it very more easy. LLM, I think Python's okay. Python's a really good language. Official Army Gamer, Python is a great language for LLMs, and you can. It's for the most part, you're leveraging libraries underneath it. So Python isn't doing the heavy lifting, but like things like PyTorch, which is libtorch, will do the heavy lifting because that's written in C, but you're actually calling it from Python. So Python works really well for that, and it's also really easy to use. And it's probably why it's one of the languages that are really prominent in data science, because you get the powerful compute of using these libraries that have been pre-compiled for you. And you can leverage Python, which is a simple language, and so it's a win-win. Only thought Python or R had libraries for ML. Every language has machine learning code. JavaScript does, right? JavaScript, TypeScript, Rust, Kotlin, Java for sure. I mean, you name it. They all have, because it's just simple math. At the end of the day, it's just simple math. It's mostly multiplication is what's happening there. And then a little bit of extra constraints with the activations to help prevent the model from exploding. So yeah, it could any language. Do you find advantages in using Rust for ML compared to Python? Yeah, because Rust is a lot faster, and especially if you're going to be building with things like maybe simple machine learning models. Or deep learning models, Rust is going to give you more performance. We did a comparison. We actually had a previous live where we compared Python and Rust for machine learning, and Rust was 2 orders of magnitude faster compared to Python. And it was impressive how much faster Rust is compared to Python. It was like 20 times faster. It was amazing. So yeah, you'd want to use Rust. That's why you'd want to use Rust. Also, it's got built-in checks and the compiler is very strict. So it's a little bit easier to prevent you from making mistakes. But it is not super easy or friendly. So that's a drawback, right? For Rust is a challenge. It's hard to use for sure. But yeah, there you go for Rust. Specifically with LLM workflows such as LangChain, for LangChain and frameworks like that, you want to use Python because it's just easier to get started. And they do have a lot of libraries that are imported that are pre-built for you in C. And so you still get a pretty good, decent amount of performance with Python and LLMs. So yeah, just use Python there. I think it's just easier to get started. Hey, I want to learn machine learning AI with Hey, AI. Okay. Hey, you want to learn AI machine learning? What should you ask for beginner? You're very confused. Okay. Start with linear regression, maybe. I think linear regression is kind of like the entry level AI, and then do support vector machine, and then do a deep learning. I think that's actually something like that. It's sort of go on that path. So linear regression first, then support vector machine, SVM, and then you can do deep learning. I think they're a little bit more straightforward. Let's see here. I'm here the first time and love your broadcast. Excellent. Anna Girl. Hey, happy to hear it. Appreciate it. Love it. Curious World, appreciate you, Steven. LangChain is for creating LLM AI agents. It is, yeah. LangChain is meant for specifically orchestrating the use of agents. And so you probably want to use Python for that. So if you're going to orchestrate, you're going to use like multiple agents, multiple models, and then you can essentially chain them together. So you can do work on one model and then take that work. I think it's one of the more easier deep learning frameworks out there. It's simpler, offers simpler and consistent interfaces. There you go. That's my recommendation. Linear regression, support vector machine, and then you can do deep learning or just standard machine learning. Torch, TensorFlow, what they do, library, that what. And Gruel. So TensorFlow and Keras, which is a higher level API on top of TensorFlow, lets you do deep learning. And then PyTorch is the same thing. They're competitors. So you can choose with but they achieve the same outcome, absolutely the same outcome. But Keras, I would say, is easier to use. So do Python and Keras if you want to do deep learning. It's easier to use. It's everything's sort of baked in and built for you. It's a machine learning framework. I would say we did a pretty good job at just kind of walking through it. So we've got a model, which is a sequential model that combines layers together to create a feed forward and a backward propagation model that allows it to be trained, but you can also use it for inferencing. Any need to learn the algorithm? Sam D. Dev, good question. You can, and I think it's helpful because then you know better what makes sense to use, where and when. Like, what is an activation? Why would you use it? What are the different kinds of activations? What is a feed forward neural network? What is SGD, stochastic gradient descent? Like all these things, they all have fancy words, but it's just math. It's just like arrays of arrays, and then you're adding and subtracting and dividing, and that's all it is. That literally is all it is. But there's a lot of fancy words behind it. People to start because the terminology is just confusing. When in reality, it's just a bunch of synonyms for the same thing, but they're fancy words and they sound fancy, and it makes it like exclusive. So we've got our sequential model here. Let's see here. Let's see, where is, I think librs is misnamed, but I think this is what we want. This is the main file. Here we go. So we build our model. It is a very small model. Look at this, you guys. Look at how small this is. How many parameters is this? It's like maybe 100 parameters at most. This is like not a lot of parameters. And this is the XOR model. So let's open up a new window here. Let's go to 2. All right. And then let's do cargo build. Actually, let's do cargo run. And then that will run this model. So check this out, you guys. So this is how the prediction works. You see here, this is our XOR model. It will predict, it essentially predicts the output by training on a bunch of iterations. Each epoch essentially is one entire loop through the data. And there's not a lot of data here. So here's the training data. We'll walk through that here in a second. You're gonna be faced with a tough decision. You're gonna see all these really fancy abstractions that help organize code in different ways, such as classes and structures, interfaces, implementations, overloading. Beware of those temptations. They make your code what you think is nicely compartmentalized and organized, but they just make it overly complicated and difficult to maintain. Keep your code super simple. Well, we can build this framework this way, and then it makes the code reuse, and we can apply all these features really quick, and it makes it seem like you're doing a really good job by creating such a powerful, abstract framework into your existing product. It's much better just to keep things simple. It really is. Like, there was a code base that was so excellently architected. It was 40,000 lines of code. We were able to completely rewrite it in just 3,000 lines of code. And it did the same thing. It did it better. It was faster, and it was easier to maintain. How can you learn Rust in a day, Stephen? I know a few compiled and interpreted languages, and I'm mid-level. Oh, you're mid-level software? Okay, so that means that Rust is basically all the other languages. The main problem with Rust is that it has a little bit of difference. It has a strict compiler, and it has built-in concurrency and memory safety up front. So some of the design patterns that you've learned from other languages do not transfer over to Rust. So you have to unlearn some things. At least just start with a hello world, of course, and then maybe try to use some of the libraries. I've got your answer, though. I've got your answer. Actually, I have a YouTube series. I have a YouTube series. I can learn Rust too. Yes, you can. You can totally learn Rust. This is the way to do it. Rust by example. Just click on this and we're good to go. You started with RU because of Nautilus trading. Never realized how lucky it was. Oh, cool. Definitely. Can I learn and get up to speed in a day? Xiam, up in a day. Rust by example? Yes. With Rust by example, absolutely. Because you will get started in a day, no problem with Rust by example. When I started learning Rust, it was before there was even docs. Get back to the code here. And then we will wrap up. All right, so here we go. This is our model, and it trains on the XOR operator, as you can see here. This is the training data. Here's the array. Here's our sequential model, very tiny model. So what you can do is you can even increase this. Like you can like bump these numbers. So you can say 5, and then you can say 6 here. For example, you can double the import, and then we'll rerun the model, and it will train a little bit more slowly because we have more neurons to build through. Wait, it panicked. Oh, it panicked. I know why. Here, it panicked because we don't have... Here's why. Check this out. When you're passing data between layers, you need to make sure that the ending number matches the following number on the line here. Because you have to, it's a matrix multiplication that's done through a transposition, which just means you're rotating the matrix, and then you're doing matrix multiplication again on the data. And this, so you got basically your input and output. So you got your input size, your output size, and then that needs to match here. So if you wanted it 6 here, you have to put it 6 here, and then it won't crash. Boom. It's going to take some time there. It's going to run, and I bet you guys it'll work now. I bet you it'll work. You're going for Rust? Excellent. Hold on. No, I swear it was supposed to work. I was oh, I know why. It's because I forgot this. The input layer has to also match the input layer. Okay, so this has to be 2. Why does it have to be 2? Because our input layer is 2 here. So I missed one part. I missed that part, you guys. All right, now I swear. I promise it'll compile and run this time. It'll work this time. It will. It'll definitely work this time. No doubt. I'm going to sit here, my hands off the keyboard. It'll work this time, and you'll see epochs starting to train. There it goes. Did it crash? Nope, no, it didn't. You're seeing the epochs train, and it's taking longer this time, and it's got more neurons. That's because we've added density to the model. We doubled the density between the layers. The hidden layer is double the size. And look, you can see that our accuracy is improved just a smidgen too as well. So you can see here, our accuracy is just a little bit better. So now that we have our XOR, and you can see that we're kind of playing with the data, one thing I wanted to do before we end stream, so we do have to end stream here pretty soon, but not right yet. We have one last thing that I wanted to achieve, and that one last thing here is to build a Threven and Throd detector. We're going to build a Threven and Throd. That is a sort of an odd and even, but with divisible by 3, you know? That's what we're going to do. Sachin, language, especially in the computer science world, is overly verbose and fancy. The language is so fancy. The deal is, it really is actually simple. You do not need... So we've got our model that we doubled in size just for fun of it, right? We can also add more epochs. Let's do that. I want to add one more. I want to add a little bit more epochs to it. Here we go. Let's double the epochs. And what we're going to see when we do that, you can see here that our prediction has a range between basically 0 and 1. Right here at the bottom, the prediction 0 and 1, you can see. So if it's close to 0, that means it's 0. If it's close to 1, that means we can consider it 1. And that is our answer. And so you can see how well the model has learned, it's trained. When we do this and we double the number of epochs, so, sir, while learning languages, what should a person focus like learning only one language and perfecting it, or learning multiple languages? Here's the deal. Sachin, here's the deal. Every language is essentially the same. They're all the same. I recommend learning Python because it's easy to read, and it has all the same design patterns that you have in every language. Flow control, if statements and checking ranges is something equal to something else. Python has that, really simple, right? And you have for loops, so you have iterations that allow you to iterate over lists. And then there you go. That's like the main compute. That's it. I mean, if you're looking at the screen right here, you can see that we have a for loop, right? The same in Python. And then we have some flow control here. right? Because you don't want to print out every epoch loss. You only want to print out every 1,000 epoch losses, right? Every 1,000, because you don't want your screen to get filled up with elation. There you go. It's got 2 L's. This lets you use a large model like an LLM, and then you use something called tool calling or tool use to get back deterministic response output. And then you have it look over a bunch of documents or images, and you ask it questions. You say, is this image green? Or is there green in this image, right? Is green in image? And then the big AI will take that data, read it, and then give you a deterministic JSON serialized output, which you can then capture that data as your training data set for your small model. And then you build a model like we're building here in Rust or PyTorch, and then you can train a small model. That's what, with that small model, we'll be able to accurately answer those questions, but at a fraction of the compute. That level of savings is what you want to put on your resume, able to create a new model that is 1,000 times more efficient. Can you please explain what you are building today? Yes. So we've got a machine learning model that is just a simple, these files are just basic vanilla Rust with few dependencies, and it's a deep learning machine framework. Isn't that cool? It's a custom machine learning framework. And here it's open source. And it's a good way to get started. I'll paste that here into our chat so you can see it. And it's running in Rust. So it's actually really straightforward. But that's what we're doing. We're playing with it, and we're going to cook. I want to go one step further. So we just changed some of the parameters. We changed the number of epochs. Oops, here, 1 second. Let's get the screen back. There we go. There we go. I want to modify this. I want to do a Threven or Throd, and then we'll in-stream why Rust is a newer language. But at PubNub, we have a lot of Rust, and so we really like it because it helps us maintain a minimal debt. It's the best for that. And it is slowly taking over C, for example. Python is going to be the language to learn, though. I think it's the most prevalent language from an AI perspective. And it can still leverage Rust and C by importing those libraries directly. And it makes it a really easy way to build your coding, but also leverage the power of those frameworks. You can still do it, and that's what libtorch is with PyTorch. And paste every word that Not Owen has posted there in the chat and write that down. Those are things that are really good to get you started for AI and machine learning. Absolutely. You can do, I think you can do Rust WASM on Solana. I think Solana. Is that spelled right? I got to spell it Solana. Here we go. Rust and WASM on Solana. I would say, yeah, Ethereum on ETH. Thank you, sir, for answering. Hopefully Rust will take over. Yeah, Kurt, it is on its way. And I tell you, we've invested a lot into Rust at PubNub, and it has been so worth it. The advantages that we have over everyone else. Here, guys, we're going to write a new function called fn get is odd or even training data, odd or even data. I think we just do this, boom, and we want to do the same thing here, like this, and then copy paste. Actually, we'll do something. Well, let's copy the whole bit here, like this, and then we just want to grab that like this. There we go. Comment some of this stuff out because we're going to change it. We're going to make it different. /. Okay, here we go. This is also one of the easier to use deep learning machine learning frameworks, and it also supports generative AI as well. No, Solana uses Rust. Okay, yeah, Solana uses Rust. Yep. MD, thanks again. Learned so much today. Thanks for gonna learn Solidity and Rust. Learn everything by doing. It will work for Rust too. Yeah. So you learn by doing. Make mistakes. It gets frustrating. You get frustrated, you'll be like, darn it. And then the Rust compiler will try to help you along the way. It'll give you recommendations. You'll implement those recommendations. And guess what? It will say you're still wrong. So it just takes patience. Just take one step at a time. One step at a time. As you saw, we were even hitting errors up here. Like, look, I was already hitting errors, right? Like main thread panic. Problem. There you go. It's because our inputs are incompatible. So wow, yeah. Anyway, the Rust is Burn AI deep learning framework, but it makes you define every detail. Still is mature, I think. Yeah, absolutely. Yeah, it's I think so. Or not mature is what you said. It's still early. like I would say, right? So currently working on some Rust deep learning. That's what we're doing. Currently working on artificial intelligence and a Rust tutorial. That's what we're doing. We're going to cook. We're going to cook with this model, with this AI. This little AI assembly is like a black hole. Now, before it ends, because I do got to get going, before I end, I want to finish this is odd or even. We got to do is odd or even. Let's see here. Let's see, X train. We want it to generate some random numbers. So how do we do random? Okay, so we'll say random lists of numbers and between 0 and we'll do like 100 or something. So X train. Let's see if we can coax the AI in here. I might not. Let's see. Let's double check. Copilot. Or we'll just have to copy paste from the internet. Copilot. There we go. Is it going to work? Synthesizing. It's thinking, you guys. 0 completions. Oh, come on. That's ridiculous. Okay. We can, so there is some existing code in here that I can copy and paste from. This is the way I like to do it. I think it is in layers. Here we go. Random. Perfect. This is what we want. We'll do it like this, you guys. We'll do it like this. X train. Boom. Boom. There we go. All right. So I've got that. Let's see here. We've got our random input. So we're going to do int uniform and then, okay, so that's the uniform, but we want it between 0 and 100. Let's see here. 0, 0. So do that. Let's see if that works. And then we'll see if we can, here we go. We don't want that there. We want that over here. Perfect. Boom. Let me go. Let's comment that out really quick. There we go. We'll just do train Y. There we go. I do believe that's it. So, and then I want to print this. I want to print that out. Get odd or even. Here we go. Perfect. All right. Now let's see what that does. Let's do our cargo run, you guys. All right. We're almost done. All I want to do is create a quick, okay. I will see. Oh, it doesn't like that. Why isn't it like that? Get odd or even. Well, why doesn't it like that? Okay, let's see. See, we're coding here, guys. We're actually coding. We see some errors. Oh, I see. Okay. Got it. It doesn't like how we did it. So I suppose, so how are we going to do this? Because isn't it not an array 2? It is an array 2. It's a float 64 array 2. That should totally be fine. Why doesn't that like that? Unreachable statement. Oh yeah, we don't care about the warnings. We don't care about the warnings. We only care about function associated item array base owned. Okay, got it. It just needs to be, it's a 1 of 1. So we just need it to be like this. Here we go. Let's just copy paste that really quick. There we go. Okay. And then it needs to be like this. And then our model is going to be a 1 and 1. So it'll be like this. We don't need a 2. It'll be 1 and 1. And let's see, 1, 2. We're just going to make it simple here. 3, 4. And then we'll just keep going like this. We don't need the dot though. We don't need the dot. Actually, we do because it's a literal, right? It needs to be a floating point. Some training sample here. So 4, 5, and we'll go 6. We'll do 7, 8, and then 9. Perfect. Are you making your own AI? Yes, that's what we did. Spicy Chip 12. Spicy Chip 12. We made our own AI, and we're playing with it now. We're gonna cook. We're gonna do is odd or even. And then we need 4. Let's get 4 as well in here. We're gonna get 4 going. We're gonna get all the numbers. Every number. We gotta make it fair. Here we go. And then what we can do is we can just copy paste this here. So we just do it like this. Copy paste into here. Boom, 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 boom. There we go. So now we've got our input and our output. So we know here we've got our numbers 0 through 10 or 1 through 9 or 0 through 9 basically. And then we know what the data. And so now we're going to train an AI model to predict the future. And I'm curious. I'm wondering if because this is kind of I think you can solve this with linear regression, but is it going to be able to detect odd and even numbers beyond 9? See here at the screen, we got beyond 9. So we'll try it. We'll see if it can predict it. I'm pretty sure it could, but we'll find out, right? We'll find out. All right, here we go. Let's see if we can cargo run. Is it going to run this time? I don't know, you guys. You missed the trait random ext. Oh, is that what I did, July? Got it. Okay. Understandable. Let's see here. Let only supported directly in conditions of... Oh, wait. No, wait. What do you mean? Let's see here. Oh. No, I'm doing it the same way I'm doing it here. See, this is why Rust is one of the challenging languages. Hey, thank you guys for the likes. I appreciate it. We're actually coding now. We're actually coding. So let's see here. Let's get there. Let's hide this so that way the compiler doesn't worry. Let's see here. Then we want to print. We want to print it. Get odd or even. I'm pretty sure. Oh, yes, we returned it. Here we go. We returned it. All right, let's see if we can get that going. Let's see if that works this time. I don't know if it will. We didn't really change much, so I guess we'll find out. I mean, it counts. This is array 2, so. Oh, we only got warnings. We only got warnings, you guys. I think we did it. Christopher, so refreshing finding a live stream that's like-minded individuals. Love this. Cool. Yeah, absolutely. This is exciting. This is the kind of things that I just do for fun, right? You just do this for fun. And you know what? It's like, instead of just doing this on my own for fun, why don't we do it live on stream? Then we can share it with you guys. So we can share it together and then we can enjoy this exciting adventure at the same time. All right, so we did it. Here's our training data. And what we can do is now we can train a model on this data. Check this out. So we should be able to easily, and so I changed our input model to be a sequence, so sequential. So input size is 1 because it's just a single number, and then output size is 1 because it's whether it's odd or even, right? And binary classification. As a self-taught guy, I really want to get into Rust, but it's hard. It is, Victor, it is so hard. Like, I was struggling right now, and I've been using Rust for a long time. Grigri, hey, who is better, Rust or Go? They're about the same, I would say, right? So if you're going to get a job in computer science or software engineering, you want to find a role that has, a popular language. The more popular languages are JavaScript, of course, TypeScript, Python. Those are the more popular languages. And then it goes to C, and then maybe Go and Rust and Java, right? Java or JVM languages like Scala, things like that.